So first of all, thank you, Dr. Shobha, for giving me chance to be a part of this workshop. So thank you for same. And hi all, good morning. So yeah, so we will be yeah. So means I joined this company about 5 years back. There seems to be some disturbance, I guess, in between. Okay,
It's fine here.
okay, that's fine. Okay, so I joined this company about 5 years back, and so I joined as a data engineer back then. So now I'm managing a team of data engineers here, and I have been working with the combination of the HPCC and the data warehouse, which is also supposed to be the topic of today's session. So we will be discussing how we can design the data warehouse using the HPCC, and we will touch base on few definitions, few keywords specific to the data warehouse and the HPCC side, with some example, with some samples. Okay. So that's one thing. So to begin with, just a second. Okay, so this is what I have done. I have divided my sessions into two segments. So in the first segment, we'll talk about data, what we do as a company, and what's data warehouse is all about. How can we define data warehouse, and how can we use the HPCC for designing the data warehouse. That's my first segment, and we'll have a short Q&A as well in between. So just if you guys have any questions in between, we can discuss out them. And in my second segment, we will be discussing about some of the claims data insight use cases. Plus, we'll take a sample data, and we'll see how we can design the data warehouse using the HPCC. We'll have a check on the data model as well, means how we design the model. Plus, we'll see bit of ECL code just to give you guys a kind of a hint how we code in the ECL for the data warehousing as well. So that's going to set up the whole tone of the session. So and yeah, we'll have one more Q&A in the end, just in case if you guys have any questions on the examples or the use cases what we have discussed, so we can take them as well. Okay. Okay, so to begin with, as a company, what we do. So in LexisNexis, we harness the power of data for giving the data insight, data solutions to our customers, which helps them in better decision making and to mitigate any possible future losses. So that's the basic funda what we do. And we have been supporting so many sectors, so many segments. So our data is not just confined within a single sector. It's been diversified as well. So we have been supporting business services, financial services, banking systems, uh, the government policies, and those all things. We have so many sectors, so many segment with us, and we have customers based out in 180 plus nations, and which contains even the top fortune companies, top banks as well. So now why I'm taking all this point, because I wanted to give you all just insight about the kind of data we have and the size of the data which we work with. Okay. So for giving any customer solutions, we have 5 pointers on which we focus much. So to begin with, the first point is again, we have a vast amount of data. So since the beginning, we started way back about 22 years back, and at that point of time, we used to have data in the physical form, but now it's been transitioned, and we have data coming in so many forms as well for today's cases, if we take that into account. So as of now, we have about 15 PBs worth of data sitting with us. So one can just think what are possible combinations and the kind of combinations of the use cases we can have on top of them. So that's the actual size of the data what we have as of now within the company. Now, to manage that much amount of data, that's a big data, to be honest. So to manage that, we have our own system design, which is the HPCC. So that works on the big data as well, as Dr. Shobha has mentioned in the first session. So So in the HPCC, we do all the heavy computations, all sort of transformations or deduping. Possible. That's something possible because the way the data has been distributed in the HPCC side, and so that's one thing we focus on. The third point is on the linking side. So this feature is something we designed, and based on that we can combine the data set, and we can have the possible match and the best possible search on top of it. So whenever someone searches for the person, even we can go and check in the nominee data as well, since we have the nominees data coming via so many vendors as well. So that's how we link the data as well. Same way for the fourth point, something based on the data science, and we use the AI as well on top of it for designing the data insight, and that's something help our customer for better decision making. Okay, so moving to the fifth one. So since anyone have any questions in between, or there seems to be some noise in between coming. Okay, I hope not. Okay, so yeah. So for the fifth point, we have the SMEs, since we have been part of this business for quite some time. So we are the data expert as well here in the sectors what we are serving, and we have the SMEs sitting with us who have been working as a customers in the past as well. So they know what a customer need and how we can serve them better. So this all five pointers is something we used for designing all the customer focused solutions. And these are the five solutions which we support, as the name of them signifies the details, means what we do in them. Okay. So till this point, we have talked about as a company what we do, and the set of services and the set of solutions what we support. So before jumping to the next topic, I just want to give you guys about 10 seconds just to think what data is all about, because now we will be touch basing the actual definitions or the concept behind the data and the data warehouse. Okay, so I'm starting the counter so that you guys can just think of what data is all about, and then we can ask, maybe some of you can come up and just say what you thought of as well. Okay, so I have started my counter. So anyone want to speak up now, or just to give us some insight about what data is all about? Okay, no issues, that's fine. So you guys might be having some big picture that that's a big chunk of data is what we call it as data as well, and a big chunk of details. So it's not that way. The data is quite simple. It can be in so many forms. It can be a quantity, it can be a number, it can be a fact, it can be information as well. So it has so many definitions, and nowadays data is the main fuel for all the sectors and the businesses what we support, and the banking sectors as well depend on the data. uh, so that's the main component in all the business cases we have. And take an example, even we can see data which is being captured by so many devices which you guys have been using. Take an example of the smartwatches, smartphones. The TV as well captures some data, which shows you guys have been watching. So all this is something based on the data what we have. Now coming to the actual definition, so we have seen what data is all about. Then what can be a data warehouse? So to jump into the definition, before that, I just want to take an example here. Take an example of the smartwatch. Okay, so in the smartwatch, most of you may be using it. Okay, so that device captures the health information such as the step count, the BP information, and so on. So that's something the device has captured for day-to-day basis. So as a person, think of a situation that just in case if you want to see which part of the day the BP has fluctuate most often for the past 1 year. So if you want to find that sort of insight, if you want to find that sort of measures on top of the data what the smartwatch has captured, some computation need to be done on top of the data. So that's something which is your phone might be doing it. You might be having some app which is doing all sort of computations, but that's something we have been computing the measures. So if we talk about that, so we are computing the measures on the context of the data what we have. So that can be computed on, say, week wise, month wise, year wise, and so on. So the measures what we have computed and the context is nothing but my facts and dimensions. So in this example, the measures was the step count and the PP information. But and the context on which we have computed the measures, this is the month wise, week wise, as I mentioned. So that becomes my dimension. So this is nothing but the basic definition what we have for the facts and dimensions, and that's how the data warehouse works as well. So in the example what we have taken, again, this is the definition what we have for the data is the fuel for all the sectors and the businesses. Okay. So the definition of the data warehouse is nothing but a collection of data coming via so many sources. So the example what we have taken for the smartwatch, that's just had a one source, which is the smartwatch, which is which has captured all the data. But in the typical data warehouse, we can have so many sources coming, and we combine the data, we commonize the data, we do some sort of data churning on top of it, and we put conditions so that we just get the data what we want, not any data which we don't need as of now. Okay. And once we have that, we compute all of the measures and the facts on top of it based on the context what we have decided, and that's something is been used by the business for the decision making. Okay. Now this data warehouse is something used by the OLAP systems. Now what this is all about is something we use the past data. Take an example that we might be using the past 2 years or 5 years worth of data to get some pattern on top of my data. Okay. Now, if we take an example that if I just want to find out for the last 5 months or maybe for the last 6 months, what was the policy count and for that given company. Okay. So in that case, if the policy count has went down in the month of means in the fourth month, then we will get to know, yeah, for this given month, the sales team has to focus on the policy count as well, so that we don't have the same mistakes done by them again. Okay. So that's also kind of giving me the insight. So based on the past data, we come up with the pattern, we define the data insight on top of it, and business or the sales team can make use of it. Okay, so that's the definition of the data warehouse. Now, some of you might be thinking then that the data warehouse, is it same as the database? So I can say no. We can, database can be a subset of data warehouse, but database is a kind of a two-dimensional data what we have. But when we are talking about the data warehouse, we can have n numbers of dimension of data, and we can compute our measures or the facts on the basis of so many dimensions, depending on business cases we are working with. If we take the same example of the smartwatch, we have computed our measures on, say, on the dimension or the context of the date, which is my month wise or week wise. Same way, we can have our measures computed in so many ways. So we'll see one example as well. When we jump into the second segment, we will take a sample data which has the policy and the claims information in it, and we'll see how we can design a data warehouse on top of it. Okay. So moving to the next one. So what if we don't have the data warehouse design? We have a huge amount of data sitting with us, but if we don't have the data warehouse on top of it, then how is going to impact my business and what all factors will come into equations? Okay. So as I mentioned that data is coming via so many form of data is coming via so many sources. So each source is going to have its own set of conventions. They might be sending us data in the CSV form. Some might be sending us data in the XML. Some might be sending in the JSON form. Some might be even just giving us the database info, go and connect the database and fetch the data. Even that sort of setup as well, we have seen with the customers. And that's something we have seen in the business cases as well. So each vendor, each data source can have its own form of data. Some might be sending 250 set of columns, some might be sending just 50 set of columns, what we needed. So so many sources are coming and kind of sending us data. That's something we used in the data warehouse. It's not just confined within a single source or single data source, what we can say. So it's a combination of all the data coming via so many sources. So in this case, since the data is not uniform, the data is not common, so it's not easy to use as well. So if you want to put some conditions, if you don't have the data in a common format, it's not possible as well. Some Take an example that one of the source who is feeding us data has the date column in the YY DD format, and some might be having the month in the starting. So if I want to put a condition on top of my combined data, it's not possible because we have to do some sort of transformation before we can use the data. So that's the whole significance behind the first point. Since the data is coming via so many formats, since the convention is not uniform, it's not easy to use as well. So that's the first issue what we faced in case we don't have the data warehouse. Second thing is on the cost side, the cost incurred. So here, since data is coming via so many sources, so the example what I've taken, that one of the vendor is sending me say 250 set of columns, but we just need 50 to 55 columns because my business is kind of dependent on them. So in that cases, we are saving that much size of data, and that's gonna consume a huge amount of space as well, which is again going to impact my cost. So the cost will be much high whenever we just work on the actual source data. So that's my second point. The third one is on the usable side. So the data won't be much usable if we are not doing any sort of transformation, since the data is coming since the data has came via so many sources, so many conventions being used by as per the sources. It's not as per the company conventions what we go with. So that won't be easy to use. And just in case if I want to put some insight on top of it, that won't be possible. Okay. So even that's not easy to use. And the fourth point is we will be not having that much amount of data inside on top of it. So take an example, we can just get the count of the data. That was the count of data what the vendor or the source system has sent us on so and so date. But just in case if you want to find out, if you want to compute any measures on top of it, that won't be possible, because before that we have to commonize the data, we have to transform the data in the common format, and then we can do some sort of computations on top of it. Okay, so these are the 4 points because of which we need to have the data warehouse design whenever we are working with the big data as well. So moving next. So how HPCC can help in designing the data warehouse? We'll see the points one by one, and somehow these points are kind of mapped with the all the points what we have seen before. That why we need the data warehouse. Okay. So in the HPCC, the parsing of the semi-structured data, which can be JSON, CSV, XML, we have consumed even PDF as well in some of the cases, and that's way faster in the HPCC because of the way the data has been distributed in the HPCC. Okay. The second point is about the heavy computations. So all the activities such as join, sort, dedupe, norm, denorm, and so on. So these are the heavy tasks. And if you are working with a big data set, which is having GBs or TBs worth of data, if we have done the data bifurcation or the data distribution in a better way in the HPCC, it's quite fast, since we can get the sorting done in much faster way. Then we have the complex facts and dimension design. So once I'm done with all my key tasks, which are join, sort, dedupe, then we are going to compute all of our measures, which is something based on the facts and dimensions, as we have seen in the first example. So we will be computing and we will be saving the facts and dimensions inside the HPCC first, and then depending on the use case that the business is having, some might want that data to be exported back to the database so that they can have the Power BI dashboard design on top of it, and some might be using the SOAP call or the web service call to search on top of the data what we have given them. So it depends on business to business cases how they want data to be used, and means how they want to ingest the facts and dimensions what we have computed in their system. So we have all the option open. We just need to have the data first computed in the HPCC, and then depending on the business need, we give them the data in the way they want. And just for the sake of debugging, just in case, we are keeping a version of the source data as well in the HPCC. Now, why this is going to help us? Because some of the source system which we connect, and some of the source system which we can have in the data warehouse, they may not be maintaining that many versions of data on their side. Some might be keeping data for the last 6 months, not beyond that. Some might be just keeping data for the last 1 month, not beyond that. So just in case if we got an issue on the customer side, and if we want to go back and see what data the source system has sent, so we don't have that information saved in the source system side. So to bypass that piece, we have to stage the data as well within the HPCC. So just in case if we get any data issues, any sort of issues, we can even show the customers that this is what the data we got, and based on that we have done so and so computations on top of it. So we will be seeing all of this point again in the coming pages, in which we will be discussing about the component, what the set of components which comes into picture when we are designing the data warehouse in the HPCC. Okay. Okay. So this is the 1 second. Yeah, it's now here. So as I mentioned, so this is how the data warehouse has been designed in the HPCC. So we are going to just talk about the design now. We will have some sample use cases as well, which we will be discussing after this. But design wise, how it's been done in the HPCC, as I mentioned that the source system can be of so many format. They might send data in the CSV, XML, JSON. Some might give us a zip data as well. So we get the data, we have the data ingested into the HPCC first of all, and we stage the data. So the point what I mentioned in the last page, the fourth point, that we have to make a copy of the customer data as well. So in the staging, that's what we are doing. We are maintaining a copy of the customer data. That's again depends on business to business. Till what point are we? Some business are saying that we have to stage the last 5 years worth of data, not beyond that, just to keep some buffers as well, so that we won't get any issues beyond the 5 years. So depending on the business need, we stage the data first of all. Once I have my data stage, which can be once in a month, once in a year, or once in a week as well, depending on the frequency of the data coming via the sources. Once my data has been staged, that's when we do all sort of heavy computations on the HPCC. And this is again why we are doing, because the way the data has been distributed in the HPCCs, that gives me option to perform all these activities much faster. So all the filter conditions, all the parsing, transformations, all sort of joining between two huge data set, and the sort, dedupe, norm, denorm, all these kind of heavy activities can be performed way faster in the HPCC. And once we are done with all this activity, we compute our facts and dimensions, we compute the measures what the business need on top of it. And then we have the actual facts and dimension data setting in the HPCC. That's what we call it as a data warehouse. In some of the cases, data warehouse can be seen as a big picture that containing so many facts and dimension. And a part of the data warehouse can be called it as data mart, which just focus on a specific use case or specific business case. Okay, so that's what the data mart and data warehouse is all about. So once we have the facts and dimension data with us, then it depends on the end user system how they want to use it. Some might be using it for the UI, some might be designing some dashboard on top of my facts and dimension data, which gives better insight to the customers that this is what the pattern we have in the data what we have been getting. Some might be using the web service, and we have that options as well. Some might be searching the data via the SOAP calls, and they can get the data what they are search for. And just in case if few of the customers want to do a bulk search, then in that case, they can use the batch systems as well. We can have the batch system set up on top of our facts and dimensions, and they can have the batch search done on top of it. In some of the cases, we have seen that the business want data to be exported back to the SQL so that they can use the way they want. They might be using it for the UI, or they might be having some sort of a next piece of code, maybe in Python or Java, which is doing all sort of things what they want. So even that's also a possible options we have. Same thing goes with the AI as well and the data science part. So all of these options is kind of we have open with the HPCC side. The first thing is the big chunk of part is something we do it on the HPCC, all sort of computations, all sort of heavy tasks. We compute our facts and dimensions. We save a copy of them in the HPCC first before exporting the data back to the end user system the way they want, and then the subsequent business can make use of it. So this is the designing part of it, the way we can design the data warehouse on the HPCC side. So this is till this point we have covered the first segment, which is something we talked about the data. We talked about what's the data warehouse is all about and how can we use the HPCC for designing the same. So any questions you guys have so far before we jump to the second segment? Okay, I hope not. Just in case if you have any questions, you can make a note again. We can discuss all the question answers in the end as well if you want. Okay.
Abhishek,
Yes.
there's a
Yes.
question, Abhishek.
Yeah.
Just a minute. I have unmuted it.
Yeah. Now it's fine. Yeah.
Yeah. Yes, yes.
There seems to be some disturbance. So can you just type in the question as well in the chat? Then that will be easy for me to see the question and the answer.
Abhishek,
Mm-hmm.
the question is
Mm-hmm.
JSON, CSV file, and XML file, why are they called as a semi-structured when they have some inbuilt structure in them?
See, when we talk about the XML, why it's been called semi-structured? Because we can have the nesting information captured in that as well. And and that's also depend on the end user how they want to use it. Say, take an example that the XML, if in a sample XML we have about 250 tags of data coming up in that, but it depends on us if we want to just fetch 50 tag, even that's an option we have open with us. Okay, so this structure is not defined by the data what we are getting. It's something defined by the way we are using it as well. And when we are talking about the CSV, it's also based on the positions, because CSV works on the positions of the data. We can get the specific column data based on the position what we have. And in some of the cases, even the customer send the XML blob data as a part of the CSV files as well. That's something even we have seen in some of the use cases. So that's why even we name CSV as the semi-structured data, because that also can contain the XML and JSON as one of the data columns in that. I hope you got the answer.
Any other questions? Uh, you can continue, Abhishek.
Okay,
Thank you.
yeah, thanks. Okay, so now we are into the second segment in which we will be talking about some of the use cases. So we are done with the definition part because that's what been used for setting up the tone for this example, and we will be seeing some use cases as well. So these are the data insights specific to the claims what we have found. Again, the examples or the sample what we are taking, these are not the actual photos, actual case numbers or the amount. This is something being changed as a part for this workshop. But yeah, this is the kind of a use cases we have caught as well in the data what we have got via so many vendors. Okay, so talking about the first use case. So here in this use case, we had a patient which went into the hospital, and he has submitted the claim for one of the company for which he has bought the policy, and that company is kind of sending us data as well. So that company was one of the data source we had, and it's been sending us the contribution data. So we have been getting that claims data and the policy data within our system, and we got to know that yeah, the so and so person has submitted so and so claims, and he got discharged on 12th of March 2019, and this was the sum amount being given to him on part of the claim what he has submitted. Okay, but within a span of same month, within a span of the few weeks or 2 weeks time, one more case was been submitted in the same company, and so this is what happened. So when someone is submitting the claim, they have to send a photo of the patient in the hospital as well. So in the first claim, this was the photo sent by to the company, and then via company that came back to us. And in the second claim, patient has also submitted the same set of information, and you can see the discharge date is again 28th of March 2019. So he has submitted the second claim in the same company, but he has used the same photo. Now this seems to be some issues, I guess, with the claim, because we can't have the same photo captured for two of the claims, and if you see the date as well, the same patient can't go to the hospital and can't submit such type of claims within a span of 1 month. So we found out this case, and we have notified the vendor or the company that yeah, the first claim is okay, but the second claim what been submitted by the patient, he has used the same photo what he has given in the claims what he has submitted before, and we have notified them that yeah, this need to be checked, and based on that they have taken the subsequent action on top of it. So this kind of cases, this kind of things is something we support to this is how we are supporting to our customers, so that they can bypass the losses which they can have in their businesses as well. So this is one of the case in which the same photo was being used by two patients for submitting the two set of claims, and we have notified our vendor or the company that yeah, this is the second the means in the second time we have notified the company that there seems to be some issue with the claims what we have got the second time. Okay, so that was one of the use cases. Coming to the second use case on the data insight for the claim. So we have been supporting the that claims as well. So the company have been giving policy to the specific beneficiary or the nominee as well, and based on that, so just giving you a quick insight that whenever a person died and he has a policy, then company has to pay a huge amount of sum to its beneficiary or the nominee what he has set up in the policy. So when we are talking about the death claim cases, the amount is quite high. So if we get such cases once in a month or two times a month, then that's a big chunk of money is going out of the company as well. So we have got one case in which is in the 21st of October 2016. The claim was submitted for one person who has which is a death case, and the company has paid a huge sum of amount to the beneficiary. Okay, but we had also one more case. So the first case is something came via one company. So the person has policy in two companies, by the way. So he has submitted the claim in the 2016 in the first company, and he got a huge sum of money as well on top of it. Then in some other company, he has also submitted the same that case claim on top of it. So so this is something, a kind of convention that if a person died, he can just have the claim taken by just one company. He cannot go and uh, get money via so many companies. He can just so this kind of information is possible because we have been getting data via so many companies, so many sources coming back to us, and we have been they have been feeding us data, and we have designed our insight on top of it. That's how we have find out such cases that this was a case, same patient name, same age, same gender. It was so we had a death claim 2 years back, and now we have got one more claim which is for the same patient, and the sum amount is also high, but via some other company. So we have notified the second company that yeah, we have got one case which has the same patient information, and that was submitted 2 years back, and this was the sum amount has been given to the patient, or the not to the patient, to the beneficiary and the nominee, so that the second company can take some means they can check the claim again, and they can pass on the message the way they want. So that's how we notified our customer that these are the possible cases in which which doesn't seem genuine, and they can take something on top of it as well. Okay, so these are the two claim specific insight what we have as of now as a part of our session. Now, before jumping into the actual data warehouse, how we can design data warehouse using a sample data. Again, I just want to mention that the sample what we have taken, that's not the actual data. We have just mimic the structure or the columns what we have, and we have designed a kind of a small data mart on top of it, not the whole data warehouse, because it's not possible to cover the whole thing into in a single session. So that's why we have just taken a small piece, a small data mart, which has the claim specific fact computed on top of it. And we will be seeing the actual model design, plus we will be seeing some ECL code snippet as well, means how we can code it in the ECL side, and how we can have the measures computed. Okay, so this is the sample data what we have taken for the next use case. And on top of this data, I'm going to design my data warehouse. So before designing or before going into the data warehouse piece, now we will be talking about this data first and what are possible questions a business can have on top of it. Okay, so my data is again being bifurcated in two segments. The first one is specific to the policy, and here we have a composite key defined on the customer number and the policy number. And then we have all sort of informations specific to the policy here captured. So for the same customer is nothing but the company who is kind of giving the policy to the specific peoples. Okay, so you can see the same company has two policies given to two specific persons, and this is the policy number, and this was the start date and the end date for same, and in which state the policy has been issued, what's the actual status, and what's the sum amount the specific person is paying each month. Okay, so in the first segment we have captured the policy specific details. Now coming to the second one, which is again based on the claims. So here we have jotted the data for the same customer and for the same policy. Now this is how the data has been bifurcated. So one customer can have so many policies tied with them. One policy can have so many claims tied with them. So it's going in kind of one to many cases. And those sort of situations, those sort of conditions, even we have to take into account whenever we are designing the data warehouse on top of it. So here we have maintained the composite key, and in that we are keeping the policy number and the customer number, and we have a new column in the composite key, which is the claim number. So on the combination of them, we can have the distinct data being saved for the claims. Plus, with my composite key, we have also captured some claim specific information, such as the date on which the claim has been submitted, what's the type of the claim we have, what was the amount paid by the company, and what's the amount given by the person for that given claim. Okay. Now, this was the second segment of the sample data what we have. Now, why I'm going in too much detail, because you will get a sense that how a business can ask question on top of this data, what are questions, or how they can use this data to get some benefit or to get some insight. Okay, so moving to the next one, which is the vehicle, again kind of based on the vehicle specific details for the given policy. So when someone has bought the policy for his own vehicles, he has to give what all vehicle details he has, such as the make, model, then in which segment the vehicle fall, what's the company name of the vehicle he has purchased, when that was manufactured. So those are the information is something we have captured. And again, we have a composite key here. So the first four columns is something we are using as a part of the composite key. Though even the third and the fourth column is also unique, because each vehicle is going to have a unique chassis number given to that. That's won't be same, I guess, for two of the vehicles. So that's also a distinct column we have. Okay, but still we are keeping the customer number and the policy number so that we can tie the vehicle back to the policy whenever we want to compute any policy specific count as well on top of the vehicles details we have. Okay, so this was the data what we are taking as a sample for the upcoming topics and the inside what we will be computing. Now on top of this data, so just by seeing this data, what all questions a business can have and how they can use this data to get some insight. So taking a kind of question which a business can ask, that in which month of this year the policy count has gone down when compared with the market standard. So the market standard is nothing but the mean of the actual policy count by so many vendors. Take an example that if we have been getting data of say 10 companies, so what we take the policy count for each one of them and we find the mean of them. So we will have a common figure that becomes my market standard. And so for the given companies, if they want to know for which specific month the policy count has went down, so that's kind of insight they can get via some chart or via some UI. So this is a UI which a business can see. Okay, and here we can see for most of the month, the policy count was way above the market standard, but for the specific span of few months, the second quarter of this year, the policy count was down when compared with the market standard. So this shows that in the starting of the financial year, the sales team has to focus on means they have to come up with some options that how they can sell the policy in this specific time span, so that they can have much high businesses and they can make some money on top of it as well. Okay, so this is one insight we can have using the policy count. Same way, the second question which can be asked is, what's the minimum policy count we have state wise? So we have seen in the past data that we have captured the state information as well in our policy data. So now can we get an insight being done on top of my state as well, that in which specific state the policy count is not up to the mark, is not matching with the market standard and is going down when compared with same, so that the sales team can focus on that specific state and they can come up with some strategy or some sort of options so that they can have high policy cell count in that specific state one. Okay, so here if we take an example. Okay, so here we can see most of the state, the policy count is much high when compared with the market standard, but except one specific state, which is West Bengal. So this insight is giving me information that in the state of West Bengal, the sales team has to do something to get some high policy count, so that they can have they can have some business model defined on top of these states, and they can make some benefits on top of it as well. Okay. So these two are the typical questions based on the policy count. Now, same way, if we take the claims into equations, so what happens, even a business or the sales team can have the positive insight used as well. So if you take the same claim data as an example, even they can show their new customers that we have the highest claim settle percentage. Now that's a kind of a method even the sales team uses. Most of the company uses even now, that they have 95% of the claims settled in the past 1 year, so that they can get some new customers, and that's going to have a huge impact on my business as well. So they can use such kind of insight on top of my the sample data or the claim data what we have been getting, and they can show their new set of customers that, yeah, see, this is my claim settle percentage, and this is the actual market standard settle percentage, and my company's percentage is way higher than when compared with the market standard. So on the basis of this insight, they can get some new customers, they can have a huge impact on the business as well. So even this kind of insight, kind of a positive insight, can be captured with the help of the data warehouse. Okay, same thing goes, just in case if I want to find out which specific specific company he's kind of submitting the claims most often. So if we talk about the companies we have for each of these vehicles, so which company has the maximum numbers of claim open for them. So even we can find out those kind of insight, because we have the vehicle data with us, which we can tie up back to the claims and the policy, and we can have all these measures computed. So we can see here we have the data computed company wise. So again, this is a sample. It's not that the Kia has the maximum numbers of claims submitted, but just to show you guys that how it's been shown to the business. Okay, this is how the business decide, yeah, this is how they will get to know that, yeah, it's just for this specific company Kia, we have got the maximum numbers of claim. So just in case in future, if someone is submitting claim for the same company, they will be a bit cautious as well with same, if they want to pass it or not. Okay, based on that, or they can decide which means what step they have to take. Okay, so these are the possible insight or possible questions one can have on top of the data, the sample data what we have seen. Now we have seen all this beautiful UI, we have seen all this, the way business sees the data, but these are the kind of a dashboard part. This is the kind of a UI part which I have shown you guys. But in the back end, it's all data warehouse. What all measures, what all facts we have computed. So if we have messed up with our data warehouse, all things will be messed up. All the measures, all the count being shown on the UI, that not going to make any sense to business, and they can't depend on such a UI as well. So all things, all the computations, all sort of measures is something we have computed way back in the data warehouse. We have the data computed and saved in the HPCC. And depending on the use case, we are kind of, maybe the dashboard team is kind of mimicking the same thing on the UI. They are showing the data in a better way on the UI side, but that's all depend on the data what we have in the data warehouse. Okay. So till this point, we have covered the UI part of it, the data what we can have. Now I'm jumping into the actual model what we have designed. Okay, means how we can get this claim specific info. Take an example of this third chart. We have been showing that this is the actual percentage of the numbers of claims being settled by this company when compared with the market standard. So here, this is a small model what we have come up with. The actual data warehouse is kind of a big structure we can have at any given time. So here we have just taken a small subset of the data warehouse. We can call it as a data mart as well, because this is something based on a specific context, which is my claims data here. We can have, and this is again based on the star schema we are using here. So if we talk about the schemas what we have in the data warehouse, we have star schema, snowflake schema, we have the fat constellation schema, and so on. So depending on the business cases, we fit in the specific schema. And so in this case, we have taken the star schema because we are just focused on the claims side. That's something we are taken as a part of this workshop as an example. But if we take the whole thing into equation, the policy, the vehicles, and the claim, it's going to be the fat constellation schema, because we will be not having a single fact. We will be having, depending on the business cases, we will be having 2 to 5 facts depending on how they want to see the data as well. If we want to add some more measures on top of it, take an example, if the claims data is business want to be bifurcated as well in some other structure, even that's going to have its own fact design on top of the data what we have got. Okay, but here for this workshop we have taken a small data set, and we have captured the all the facts and dimensions for the specific use case. So I hope you guys can see the font. Is it visible? This is quite small, I guess.
Fine, Abhishek.
Okay.
I think it makes sense.
Okay, that makes sense. Okay, so what we have done here, so we have again divided our data into facts and dimensions. So in the center, we have a facts designed, and so we have all sort of dimension design on top of the data as well. So take an example that in my fact, we don't want to have all the data captured, say customer name, customer contact information. So that's something I'm designing dimension on top of it. So we will be having a single dimension data, dimension table or dimension file, which is going to have just customer specific information. And that's my first dimension, which is a DM customer. It's going to have customer number SK. Now this SK is nothing but my sequence key, which I'm using for joining the data back to the fact. So we will be having just a number, the sequence key saved in the fact instead of saving the whole set of information, because whenever we are joining this fact with our dimension, the if we are using the numbers, it's going to join faster instead of going via the textual specific columns. Okay, so that's why we have the SK computed. It's going to be a sequence number being made on the dimension side, and the same dimension data, same dimension SK, we can have it in the fact. So this is something we did for one of the dimension for DM customer, which has the sequence key, customer number sequence key. We have the customer number, name, contact information, customer source, and so on. So all the customer specific information we have jotted in a single dimension. Okay, and why we have done this, because even this DM dimension can be used in some other data warehouse as well, in some other data mart as well. It's not that we are just confining it to be used within this specific fact or specific model. We can use it as a confirmed dimension, so that the same dimension can be used by so many facts. Okay, same thing goes with the DM state, in which we are maintaining the date specific columns, whether it's which quarter number the date falls, what's the start date for the quarter, what's the end date, what's the month name. So just in case if customer want to see for which specific month they have the claim count open, they just have to join the facts with the dim date, and they can get the month name, and they can get the computed data as well on top of it. Okay, so all the date specific column we are jotting, and we are saving it as a part of the dim date. Again, this is a confirmed dimension, can be used by so many fact. So most of the dimension what we design is something that can be used by so many facts, so many data warehouse, and we have a huge data warehouse sitting with us. So these are the kind of a common dimension we use in between them. Same thing goes with the DS policy tenure. What's the specific tenure, whether it's of 6 months, 1 year, and so on. So those set of, we can have a context defined on top of the tenure of the policy. And based on that, a business can even search for which specific tenure they have a highest policy count and so on. Okay, same thing goes with the policy type, state, claim type, and the claim status. So all these are the context of the data on which I am computing my measures. Now a question can come: how can we say that the data warehouse is not a two-dimension data? Because my measures, say take an example that the first measure which we are computing is the claim open count, is kind of computed on the combination of all these SKs. So whenever I just want to get the data via state wise, so I just have to sum up all my measures with the help of claim state SK. So we will be getting all the measures on top of my states. Same way, if I want to have data computed on a combination of dimension, such as they want to come they want to fetch a data, they want to fetch measures on top of the state wise and month wise as well, that for the given month which specific state has the highest and the mean and the maximum policy count or the claim open count. So that's also possible. So so we are giving options to the business that on so many set of dimensions they can have the measures computed, and based on the need they can show it to the on the UI depending on the business cases we are working. Okay, So all the claim specific count we have seen, which is claim open count, close count, paid count, and the sum amount tied with the claim, and what's the close claim amount been given by the company to the specific beneficiary. So those set of information we can capture here, those set of measures we can compute here, and depending on the context of all this dimension, whenever we want, we can fetch the specific measures on top of it. Okay, so this was a small data model what we have come up with, kind of a small data mart we have taken as an example instead of going for the whole big picture. Okay, so moving to the next one. So now we will be just seeing a bit of ECL's code, not going in too much detail because I guess we don't have time as well. And we will, so just wanted to give you all just a kind of a insight of some details on how we do all such things. So we talked about we have to commonize the data, we talked about we have to compute our measures on top of my dimensions, and we have to save the facts and dimensions in the HPCC side. So those all things is something we will be just kind of touching up via the code. Okay, so this first code snippet is something we do as a part of the data transformation. As I mentioned that the policy data, what's been given, what's coming via data sources, we have to commonize the data first. So some might be giving the dates in some specific format. So we wanted to have our own set of conventions, and we wanted to transform the data coming via the data source to that specific convention we want, so that we can have a common convention on the data, on the combined data, and then we can get some insight on top of it, or we can do some sort of computations on top of it. So here we can see that we have been transforming the dates into a specific format, and we are discarding some special symbols, which is something coming via data, just in case if they are sending the data in the camel case, we are converting the case as well. And if we have commas coming in the data, because in the sum amount, if we customer or the vendor might be sending comma as well if the numbers is in thousands. So, but we can't use the comma while summing up the data. So that's something we are taking it out. Okay, so all sort of transformation we are doing, and then while saving the data as well, we are maintaining that we will be having just a distinct data, customer number and the policy number wise. So just in case if the same vendor or the same data sources send us the same data again twice within a span of few days, we will be just maintaining, or we will be just keeping the newest data because of the sort and dedupe we have done here. Okay, and how we are keeping the newest data, because we have done the sorting in the descending form on the work unit ID. So that's going to give me the newest data first, and then it's going to do the deduping on top of it. So each time we have such cases in which the same policy data can show up, then in that case we will be just keeping the newest version of it, and then we are saving it into our staging data, as we have seen in the designing part. So this is just a small snippet. Again, the actual code, the actual business case in which we work is much complex and much vast than what we are seeing here. But just to give you guys a hint of what we do, so this is a small transformation piece what we have here. Okay. So moving to the next piece, so we have seen what sort of transformation we can do on the ECL side. Now, how we can make the facts, how we can define, means how we can compute our measures on top of it. So I'm just going to take some time going in this code. So we will be taking the same example that the claims model what we have seen before. So here, first thing what we want to do is we wanted to get just those claims for which we have the policy information given back to us. So that's why we are joining our data, the policy data, with our claim data set, and we are joining on the basis of the customer number and the policy number. So we are not keeping the claim number because claim number won't be we won't be having in the policy staging data. That's something specific to the claim data. So on the basis of this joining, we will be just getting those claims for which we have the policy data shown up in the policy staging files. Okay. Now, if you have noticed that we have done the data distribution here, Now, this policy data, the claim data is a kind of huge data set. So on a given instance, we can have GBs worth of data coming in them, and joining that much amount of data, we have to do the distribution on top of the columns what we wanted. So you have seen that we are using the customer number and the policy number for the data distribution, and we are using the hash function on top of it, and we are using the same column even for joining as well. The sequence matters as well. So whenever we are doing this sort of distribution, the same sequence I have to maintain in my joining conditions as well. Then my join is going to be is going to perform faster. Same way, once I am joining my data set, we are getting claim specific columns. You can see here. Okay, so we can see here that we have all the claims specific columns captured here. Plus, we have also maintained the policy specific column. So this join data set is going to give me a structure which has both the claims and the policy columns. And on top of it, then one by one, I'm going to join that joined data set, that combined data set to my dimensions. So these are the set of dimensions we have captured, which can have dim date, claim type, dim customers, and so on. So all the dimensions, again, the joining part, I am just taking some of the dimension joining snippet here, not all of them, because most of them will be having the same conventions. So we are joining our combined data set with the dim date to to get the specific start date info. Same way, we can join our data set, that combined data set with the claim type dimension to get the specific SK. Now, this is the SK which I was talking about in the design that we can use for computing the measures. So once I have all this dimension data joined and once I have all the SKs computed, that's when I'm doing my final computations. I'm summing up my data on the basis of the combination of all these SKs. So you can see it here in the bottom, we are doing a table. And here, this is the structure of the table which we are getting. And here we are computing all the measures, the claim open count, close count, and so on. And we are doing all sort of computations on the combination of all the SKs we have captured, all the SKs coming via the dimensions. So that's how I'm going to have the data visible in my fact. And once I have the data set, once I have the data of the fact data in my data set, I'm saving it in a file on the HPCC side, and depending on the business case, the team is going to make use of same. So this was the coding part, means how we do it on the HPCC side and how we compute all the measures. So I guess I'm done with all my topics. And you guys have any questions on the use cases or the sample cases what we have discussed before we wind up this session? Any questions?
All this is can you hear me, Abhishek?
Yes, yes, now I can.
So all this is in a distributed environment, right, Abhishek?
Yes.
And approximately how much amount of data is processed?
So if I just give you one example for one of the biggest model what we have designed, the source data was in 150 TBs, and we have designed about 450 GBs worth of fact data on top of it. So now you will get a sense that we are confining the data in so much way, and we are computing measures on top of it.
Any other questions? Any other questions?
Okay, thank you, Abhishek, for giving the insights on data warehousing on HPCC platforms. Okay, I'll revert back to you regarding this thing as a part of curriculum to our
Sure.
RV college students. We'll revert back to you. Thank you so much. It was a good presentation. Thank you.
Yeah. Thank you all and good day. Bye.
Bye. Bye. Bye.